So one of the problems that we have when we're using our motors the way we have been, by just going full speed 100%, full reverse 75%, or partial reverse 75%, is that sometimes the motions are not quite as accurate as we'd like them to be. As a result of this, we do require some, well, as a result of this, we get some imprecise motions. And when it comes time to actually navigating mazes and things like that, you may need a higher degree of precision in your robot and its motion. So because of this, we start to use what are called encoders. So just to show you how that works, we're going to go into Arduino, and I'm just going to start up a blank sketch, and we're going to write up some functions and a quick program that talks about how to use the encoders. Now, to start off with here, we're going to go to File and Examples, and I just want bare minimum. All right, I am a firm believer in starting all of my programs when I'm teaching from the bare minimum, and that way you get used to doing all of the stuff, because I find that sometimes you can get a little bit complacent when you're starting to use too much code written by other people. So the very first thing I do is we'll go Save As, and we'll go Encoder Example. All right, that is step one, and I'm going to put this onto the desktop. Next, we're going to go up to the top here, and we are going to include the Prism library, like so. All right, prism.h, like so, and we're going to create an object of type prism. And just for the sake of brevity, I'm just going to call it P. Now, this object here basically allows us to access all the functions inside the Prism library. So anytime I do things like turn the motors on, I have to go P dot turn the motors on, because that turn the motors on function is hopefully sitting inside Prism somewhere. If I have functions that I write myself and I put them down here, you don't need the P in front of them, because the program already knows to look for them down here. All right. So to continue along here in our basic program, we need two more lines, and they go in setup, and one of them is P dot prism begin. Like so. And that basically just allows the microcontroller, I believe, to initialize or something like that. And then the second thing that we need to do is prism set motor invert 1 1. Now, this set motor invert is basically just so that we can have the one of the motors be fed its instructions backwards, because naturally when you have two motors sitting on your chassis, one is flipped with respect to the other. So if you say go forwards to both motors, well, guess what happens? It goes in circles, because one motor forwards is really backwards. All right, or at least forwards for the motor is backwards for the chassis. So we automatically put this line in. And I think that's pretty much most of the stuff that we need to do with our setup for the moment. I'm going to introduce you to two functions called, well, one function called read encoder count. But to do that, we need to actually get the program going first. So what I would like to do is I would like to write some encoder functions that do something really, really simple. Something like this. Forward by centimeters. All right, where this would be, distance, and this would be speed. All right. Now, you're probably looking at this video going, ha ha ha, he typed sped there. Well, for some strange reason, it turns out speed is actually a reserved word, and it's orange. So anytime you do that, you can't use that word as a variable in a function. And I'm just putting these in as placeholders. Distance and speed should actually be numbers here. All right. Be nice to have a function that's backward by centimeters, like so. And we'll do the same thing here, distance and speed. Okay. Be nice to have, you know, turn left by degrees. Okay. I'll just do it DEG. And we'll do the same thing here, except instead of distance and speed, we're going to put degrees and speed. All right. You should always try and make your functions take information that's readable and understandable. So naturally, we're not going to say distance when we're turning, because that should be really measured in degrees. Okay. So be awfully nice if I had these 4 functions sitting here, but guess what? I don't. So because of that, we actually have to create these functions, and I do that down here. Okay. So the very first thing I do is I create 4 empty function bodies. All right. And just like the other functions like void setup and void loop, all right, I have void, and then I take my function name like this, and I type it in. Now, I have to put one extra addition in here, and that is when you define a function, all right, you have to say what type of variable distance and speed are. And because we're working with these Torquedo motors, it actually turns out that these are integers, but they're very, very, very large, long integers. And the int variable sometimes doesn't react very well to very big, large numbers. So instead of saying int here, you know how sometimes if I need something to be an integer, I'll put in int. I'm going to try putting this other thing called long in. All right, and don't worry about what it is other than long is a really big int. So we can always just put that as a comment. Long is a really big int. All right, that doesn't mean it always is. Like long can be 0 and 1 and 10 and -4 and any of those smaller numbers. But it could also be, say, positive 5 trillion, and I don't think int can actually be that big. All right, so just because sometimes the numbers get a little bit large when working with the encoders and stuff, we need to sort of put these functions in. So just like I did here, I'm going to now type my other function names in quickly. So I have forwards and backwards, like so. All right, and our comments come in, good. And then I have my other function here. So I'm going to put in void, turn left by degrees, long degrees, long speed, and I have to put brackets underneath. You don't put semicolons after these, you just put brackets in. All right, and then I'm going to copy this function and I'm going to plop it in down here and just make one single change, which is turn right by degrees. All right, now a couple of things we have to talk about when it comes to encoders is that encoders are just used as a really, really, really accurate way of telling the microcontroller how many times a wheel has turned or by how much it's turned, and by doing it very, very accurately. So what happens is that for every turn of the wheel, this little sensor on the motor, which is the encoder, ticks. And in this case, it ticks for 1,440 times every wheel rotation. And that actually turns out to tick 4 times for every degree that the wheel moves. So it'd be kind of cool if we could somehow track that number. So for example, if the wheel, and I'm just going to put this as a comment, we don't have to put this in afterwards, but if the wheel turns once, all right, it turns out that I should have in my encoder a number 1440 being stored there. All right, if the wheel turns twice, all right, then the encoder should have ticked 2,880 times. All right, now if an encoder has its number that it stores in its sensor as 2,880 and it turns backwards by, let's say, oh, I don't know, one full turn, then the number decreases by 1,440 and goes back to this number again. And if I turn backwards again, let's say by only half a turn this time, we're only going to subtract 720 and we're going to end up with this number. All right, so it's basically just the more the wheel turns forwards, the higher this number gets. The more it turns backwards, the smaller the number gets. And let's say the wheel does another half turn, I'll end up back at 0. Let's say the wheel does a quarter turn backwards now from 0 position. I end up with negative 360. All right, and as I say, the more the wheel turns forwards, the higher the number gets, and the more it turns backwards, the more negative it gets. All right, or sorry, the lower it gets, and eventually to 0 and into the negative numbers. And it's not strange for you to be using your robot for an extended period of time, check the encoder, and realize it's some gigantic number or some really gigantic negative number representing the fact that it's turned either forwards or backwards lots and lots and lots of times. All right, so these encoders are useful because, again, they allow us to turn the wheel very precisely. Okay, now one other thing I noticed, which is a bit of a bug here, I believe in the encoder software, or maybe the encoders itself, is that if you let them run for too long, they tend to crop up and get errors in them. And I'm not really totally sure where those errors are coming from, so I decided to put a little a kludge into the functions that we're writing, these ones here, forward, backward, turn left, turn right. And to do that, we are going to put in a function call to this thing called p.reset encoders. All right, and all this does is whatever the number is for our encoder, so if it's something like this, and I call reset encoders, and then I check to see what my motor's tick rate is at, or tick mark is at, it'll be at 0. Okay, so the idea is that in these functions, I'm constantly going and resetting my encoders back to 0.